My name is Philipp Bolliger, and I'm going to be talking to you about low power, low cost asset tracking and how we can help as Thingstream actually make that happen. Maybe quick introductions. The company, Thingstream, if you haven't heard of the company, that's okay, it's rather new. However, if you've been to the show, you should have seen the booth. If not, then I invite you to come and see us at C320. It's a newly formed division of Myriad Group, which has been around for some 25, 28 years. So while this is a new company, the team that has been working on this has actually a lot of experience with the technologies we use and long-standing business relations with the partners that are required to do that. We're headquartered in UK and Switzerland as group and project. We have offices in South Africa as well. We do, as I said, have the heritage of working in this sector and supplying primarily telecoms and MNOs with technology such as USSD gateways, and we're going to go into the detail of what USSD is. Proven technology, key element to making something like that happen. All of the elements that we're going to be talking about have been used in one form or another, so nothing is really new. New with what we do is how we combine it. So, asset tracking, and particularly if you want to do it low power and if you want to do it at low cost. There is a reason why you want to do both low cost and low power. For example, if you want to track cargo, be it on a ship or on a truck, there's things that move around, usually over long, long distances, and quite often they cross borders. So that is a challenge in itself, as you have to make sure there is coverage throughout the whole destination and where you start. Throughout the route, you want to have coverage. Another example would be, and we're waiting for the slide. There we go. If you are a supplier of diesel engines for locomotives such as this one, and you want to track and monitor your diesel engine because you're interested in the vital parameters of that engine. Again, this is a thing that moves over large distances, and in most use cases does this cross-border. Different use case. Smoke alarms, completely different. These things don't move at all. However, you mostly run them on batteries, so you cannot rely on a power source to just be there. Now you'd say, okay, but this is, oh sorry, it did not yet switch. Yes, there we go. This is being used in the home. Home, I have Wi-Fi, or I might have Zigbee, or whatever. Yes, you might, but there is no guarantee that you do. So if you are a supplier of smoke alarms and you, at the point of manufacturing those things, don't yet know where they go, however, you want to create a business model where you cooperate with an insurance company and you just want to make sure that these things, once they're out in the field, they report on a daily basis where they are and where they're still alive. You need to take care of that, and you cannot rely on any infrastructure to be there. Another very interesting use case in the remote monitoring area, again, not really moving around, agriculture, and a lot of sensors are being put in the fields more and more so. However, particularly with this use case, the agriculture is usually, it's not the urban space, it's not where you have the best of coverage, not with any network. So to actually get a signal out of the ground, usually, or very close to the ground, is a huge challenge. And again, you want to do that with just a battery. So, in summary, the challenges of asset tracking are, but first, things usually move around. That's why you want to track and trace. Secondly, very rarely do you have an infrastructure in place, or you can rely on an infrastructure, particularly on a larger scale. Thirdly, things are often in places that are very challenging for radio, as with the agriculture, for example. If you put this thing to the ground or close to the ground, that's not the best position for an antenna to be in, so you end up using more power to drive the amplifiers or any of that. And in most use cases, there is no power source. So you have to rely on battery power, and you don't want to go and change those batteries every other day or every other month. That's not good enough. In a lot of these use cases, you would just put the things out, and they must run for months, years even. And lastly, if you want to track an asset or remote monitor an asset, the cheaper the better. Simply because the cheaper the solution is, the more use cases you have. Yes, you can do all of that, but you end up spending quite a lot of money if you just take whatever's there. And by that, you prohibit yourself from going into most of the use cases we've actually seen. The elements that are required to do that, slightly technical view, well, first of all, no luck with this. First of all, you have the devices, and you need to make sure that these devices can somehow connect to the internet. That's basically the underlying truth for IoT in itself. You can do that through different means. Once you have the data in the cloud, you need to make sure you can actually process it, maybe store it, and then eventually move it into an enterprise system where you have the domain know-how, where you do the data logic, where you have your IoT application, and you can do something meaningful with the data. Thingstream, we provide you with the connectivity part of it. What we've done is we've created new tech that allows you to have a very small part of software on a device, use very low power, transmit that data, and we're using the GSM networks in a very particular way. And the second part is we help you to pre-process that data so that's easily available for you to process in an enterprise application system. Back again, you want to do that. You want to have asset tracking, remote monitoring solutions. And of course, there is different use cases as we have seen. And all of these use cases come with different requirements and different prerequisites, be it cost or coverage, battery lifetime, all of that. And there's different solutions that are the best fit for any solution. And it might just be that Wi-Fi is good enough. The Wi-Fi is a very local thing. However, if you're requiring the high bandwidth, that might be the right solution for you. If you look at LoRa, low bandwidth, very low power, very good. However, there needs to be an infrastructure in place. And that's the case in some cities nowadays. If it's not the case, you can put it up yourself, but you need to take care of the infrastructure, which again involves cost and usually takes a lot of time, and it's not as easy as you would think to set up such an infrastructure because you need to actually physically go out there and find someone that would allow you to put it out there. If you look at another company, very good in terms of power, in terms of reach and coverage. However, coverage on a global level, again, is slightly difficult because it's just not globally available. In some countries, some areas, there's very good performance that you get out of it. But if you have things that move throughout the US or throughout Europe, it's not good enough. And with Thingstream, you get the world. The global connectivity, as I said, we get that from partnering with over 600 MNOs worldwide and working with them to leverage the already installed and already available GSM networks. Now we do that in a particularly clever way, which means we actually don't use any IP up to the cloud. And not using IP throughout the whole radio part is also a large advantage when it comes to security. And finally, we do optimize it. We do dynamic signal strength hopping. The 600 MNOs, there's not 600 countries, so in almost all countries, and we're available in 190 countries, so it's just, I think, 5 or 4 that are missing. We work with more than one MNO, so our solution actually changes the carrier and switches networks from one transmission to the other, figuring out which gives you the best coverage, where you have the best connection, switches to that one, which again helps you to get your data out in a shorter time and save battery. How do we do that? Well, the first ingredient to it is, for the connectivity part, while basing on a GSM, we're not using cellular data, but we're using USSD. I'm going to go into a little bit more detail what that is. just out of curiosity, who is already familiar with USSD? Who knows what USSD means? Hands up. 1, 2, 3. No, you guys don't count. 3 people, great. But you've all used it. Are you actually using it right now without knowing? Because it has been around since 2G. Second part is MQTT end-to-end. Our solution uses MQTT even from the device, and there you have your protocol. You don't need to take care of the protocol part and how to get the data out of the device and how to do quality of service between the devices and the cloud. We take care of that. And because it's MQTT end-to-end, and MQTT actually is kind of de facto protocol for the IoT. So it's very easy to connect with whatever MQTT client you want and consume the data in an enterprise application system. So the 2 key elements of Thingstream as a solution, USSD and MQTT. I said USSD, you already are familiar with it, but you probably have forgotten. Something like *99# maybe sounds familiar. You've probably used it back in feature phones days to configure your voicemail, which was just an inbox. Or maybe you've used it to top up your prepaid mobile account. It's not very common as a use case day to day, neither in Europe nor in the US anymore. However, if I say you still use it, you do actually. If you go into your smartphone and you go to the settings, you change some of the voicemail settings, whether it should be doing call forwarding or not, in the background, the iOS or Android just sends out a USSD message to the MNO. That's what happens. So it's still around. In other parts of the world, still very much in use, particularly where you don't yet have the smartphones. Africa, India, where the feature phone is prevalent, they use it for all different kinds of stuff. Mobile banking is a very popular application, for example, all based on USSD. In Egypt, you can actually access Facebook through the USSD with a simple menu structure. So it's been around since years, part of the GSM standard. Might be similar to SMS, but it is not SMS. Other than SMS, what USSD can do for you is it actually creates a real-time connection. So there is the concept of a session with USSD, and secondly, it allows you a two-way exchange. So it actually is bi-directional, which again is a huge advantage when it comes to actually using MQTT. Has been around, works on 2G, 3G, 4G, and will work beyond. So yes, it's somewhat new technology, but it is here, it's being used, it's a key element of the GSM infrastructure, and that's one of the reasons why it will be there in the future as well. Second part, MQTT. Now, I'm sure there's more people in the room that are familiar with MQTT. I said, pretty much by now, the de facto standard and becoming more and more popular in the IoT space. Very lightweight event messaging protocol that allows you with publish and subscribe mechanisms to consume and publish data. You have a broker that is then sending out the data to the sources that are to the sinks that are subscribed to it. The standard party has actually done an amazing work improving that to be even more lightweight and to be even more efficient. Those are not our numbers, but a study has shown that if you compare it with the standard HTTPS connection, it's actually much better. You can get up to 93 times higher mobile throughput, using 11 times less power to send and up to 170 times less power to receive. So you get that just by using MQTT. And we use, for the device part of it, a particular variant of MQTT, which is MQTT SN, SN short for Sensing Network. And this, again, standard, it's not us doing it, it's us supplying it to this problem. MQTT SN allows for a few more things. It does very clever stuff, such as aliasing capabilities, which reduce the payload. You have, even if you might have defined very large topic names, MQTT SN does some magic to reduce that. There's some data compression in it. It allows for a new mode, which is called Fireandforget, which is just really The radio wakes up, you send the message, and the radio goes back to sleep, and nothing else happens, no echo, nothing, and it's very, very efficient. And if that is okay in your use case, then you're very well off with MQTT. It uses, again, less time to transmit, and the way we implemented it, and those are our numbers, those would be our requirements. The SDK, the Thingstream SDK that needs to be installed on the modem, actually uses very, very little, both flash and RAM. It's 12K and 5K. That is a good thing because it also allows you to go for cheaper hardware and you don't need to have a lot of very expensive flash on the device. Side note on that, we're not a device company, so you still need to buy a modem from one of the modem suppliers, be it Sierra or Elite, u-blox, and we are working with all of them, and we have the SDK running on all of them, on all of the modules. So if you decide to go for a particular u-blox modem, either the SDK is already available for that one, or we can make it happen in very short time. Because it is MQTT, there is a key element in this infrastructure, which is the MQTT broker. So now, let's say we have thousands, hundreds of millions of devices out there using MQTTs and sending messages to the cloud. And we need to handle that. And what you want to have is, you want to have a very scalable, very low latency MQTT broker in the cloud. But you don't want to actually take care of it yourself. And we do that for you as well. That's one of the key elements that the team has actually a lot of experience in. The MQTT broker infrastructure that we provide for you has been used for different projects previously, and this number is not any number, but it's a proven number that we have seen. It can handle easily billions of messages with zero latency. And again, because for the devices it's MQTT, it's QoS -1, that's the blind fire and forget, you have all of those modes. And our MQTT broker is fully 311 compliant, unlike some other cloud-based stuff. Is it easy to use? Because again, that's a key element of how you can actually get to market in a short time. Yes, it is. The team has done a tremendous job taking Node-RED, which probably a lot of you are familiar with. We've seen a lot of Node-RED adaptions on the show, and used it to create a data flow manager that allows you to easily figure out how to do some pre-processing of the data. So if you need to transform the data into a different format, if you need to actually do some logic, as for example, a very popular one of these function nodes is the cell tower to GPS or to location node. If you have a GPS module on your device, but you don't get the GPS signal, maybe because you're indoors, or maybe because it didn't have enough time to wake up and get a signal, you just have the cell tower ID. We can help you use different magic to actually get your location, which, if you are in a city, for example, is rather accurate. But there's more to that. There is functionality built in that help you to easily connect to different enterprise adapters. If you don't want to have your own MQTT client to consume the data, but if you're using TIBCO messaging, for example, there is pre-built adapters. You just drag it in the flow, and the data will be moved to your enterprise application. And another capability which we're actually really proud of is it's really easy to go from test and prototype to a live system. It's just one click. And if you do that, the one click will actually spin up virtual machines just for your instance to run your flow and make sure your version of that flow scales. In the beginning, we said one of the challenges when it comes to asset tracking and remote monitoring is cost. And the cheaper, the better. And this is, as we've seen, a particularly important element. We've seen a lot of use cases where people want to do this or that, but they cannot afford the current cost they have, neither BOM, nor, and that's usually the bigger problem, the cost you have to operate the system. If you compare that, if you compare what we do, what do you need? And probably the best to compare is actually cellular, because It's the only solution where you might get so close in terms of global availability and being available everywhere, really. Well, you need data, you need to send data, which at the currently available cheaper end is maybe 30 cents a month per megabyte. If it is cellular, you need to take care of activation, line rental, SIM management, which is, again, probably about $1. You need to take care of roaming fees, or if you're working with an MNO, not, but then the cost per megabyte of data is higher. You need to take care of device management. There's different suppliers that do that, ranging somewhere in the 50 cents a month range. You need to take care of the security part of it. And if you want to use MQTT, you need an MQTT broker, someone who does the MQTT brokerage in the cloud for you, which is a costly element. So even without knowing all of these price tags, because they can be variable, and we're not putting anything up, but you end up paying $2 to $3 a month if you want to do something like it. And again, this would be cellular, so you use more power than our solution, and you would actually not get the coverage as good enough. We package all of that in one simple version. We give you the connectivity, the security. You don't need to take care of roaming, none of that. You will never ever notice when this thing switches. Plus the MQTT broker and everything that comes with it, including the data flow manager, starting at 25 cents a month. That gives you 500 MQTT messages. There's different price plans. If you want to send more messages, prices will increase. The most we have is the $2 price tag, so even at that one, it is actually very, very, very competitive. Another very key element when it comes to creating an asset tracking and actually doing IoT is we've seen a lot of customers starting an IoT project, and it starts with a prototype. You need to first figure out the tech, you need to figure out what it can do, you need to figure out the accuracy of the sensors you use or the accuracy of the location systems you use, to then actually start refining your business case, maybe even refining your business model or your strategy. So a key element is to do that and to do many alterations of it in a very, very short time. And there again, we have a crucial element of advantage. The key components to get to a prototype or to a POC, first of all, you need the hardware. You need something that you can play with. You can go with Raspberry Pi or different solutions. There is stuff that you can buy off the shelf and start doing something. Second, you need to take care of the radio. It might be a difficult challenge. If you go for a LoRaWAN, it might be in place because you're only doing it locally on a city level in a particular city, and that's some of the use cases we've seen with our customers. In the agricultural space, it was not there. There was no coverage, so they had to take care of building out the network first, which delayed the whole project by 4 months, negotiating with the farmer. There is only one hill where the antenna should actually go. This hill then suddenly was an issue for the farmer. He didn't want the antenna up there. So all of doing that just takes more time. And you need to build your data flow, you need to figure out which system to use, you need to figure out how to configure the application logic and what you can do with it. And finally, you want to have some form of UI to showcase what you can do. And that, as we've seen and experienced ourselves, takes about 12 weeks. And we've built different things that help you with it. We've seen the data flow manager, we've seen the MQTT broker. You don't need to take care of any of that. You just put in one of our SIMs, go to the platform, register the SIM, and it just works globally. The other part is the hardware and the antenna. That might be difficult, so we help you out with that one as well. We've built a prototype for you. It's not a device meant to be used in real-time use cases, but as a prototype or just to check actually our promise of coverage, whether this is true or not. A simple button, which you can get from our website, has a GPS module, has a modem, has a SIM card, and that's pretty much it. You can press a button, the button will actually do a connection, and in the data flow manager you can configure what you want to happen. The standard is just figure out where it is, send you an email or an SMS, so you can check whether you have coverage or you need coverage. If if that is not good enough, or if you want to have more or build something, there's also starter kits available from our webpage, which help you to just simply get started actually within days or even shorter. So compared to other solutions, where we see, and we've experienced 10 to 12, maybe even 14, 16 weeks, you can do a prototype and a POC, technically, in 2 to 4 weeks using Thingstream. It might be a bold statement, so maybe let's also look at what our customers say, and we do have quite a few customers in different use cases. All the examples I've shown you previously are customers we actually have and that do have this one problem. Richard Creighton from Digital Twin, for example, said platform delivers ubiquitous communication without being tied to any provider at an unparalleled price point. I'm very proud of people like Richard saying stuff like this. And we're even more proud to come here to Barcelona and announce one very important customer for us, which is Rolls-Royce. I'm sure you're familiar with the Rolls-Royce Aero IoT. They have done it for years. They completely transformed their business model in the Aero. You cannot actually buy an engine from Rolls-Royce and put it onto your airplane. You just buy power by the hour, and they take care of all of the rest of it. The different use case maybe, that's not a low power, wide area use case. They have terabytes of data in a very short time for this one. But in the Rolls-Royce enterprise, there is different other outlets, and one of them is the German company MTU. It's a diesel engine company for locomotives and marine use. And through our partner Pathfinder, we are now enabling MTU to do what their Aero counterparts did and completely transform their business model. Our partner has integrated our tech into a clever hardware piece that goes on every engine, so they can actually track and trace, remote monitor the vital parameters of each and every engine. Very proud that we actually won this. It was a hard competition. It's not easy to get into Rolls-Royce, but we've done it. And one final example before going to Q&A that I would like to show you. It's not a typical use case maybe for Thingstream, but I like it because it's cute and also because it shows what we can do. Another customer we have is PawTrack, a consumer company. It's a collar for cats. It's a very slim, very lightweight thing. The cats actually don't mind too much. Allows you to track your cat, and it allows you to do that wherever the cat goes. This company sells the product pretty much worldwide. They're just now trying to figure out their next steps. There's a few thousand out there. And their CEO was actually rather impressed when he got an email from one of his customers who said, look at this, I'm tracking my cat and I don't believe it's working. He's tracking his cat in Kathmandu, and it just works. Using Thingstream, this cat, I don't even know where that is, but it just works. And this was mind-blowing. He didn't expect it, the customer didn't expect it, the CEO of PawTrack didn't expect it. And said, yeah, well, that's what we do. I very much like this story, obviously. So in short, IoT, using Thingstream, you get incredible coverage like no one else. It's better than cellular because it is USSD. Even if 4G is done and 3G is done and voice is done, you can still send SMS, and that's the point where USSD still works. So we do have better coverage than the standard cellular connection. It's short time to market because the infrastructure is already there. We help you with the prototyping. We don't just give you the pure connectivity part, but we provide the whole MQTT stack, device to device, end to end for you. It's low cost, as we've seen, not just building the things, because you can go for actually hardware parts that are not too expensive because the requirements are very little bit. Also because the cost of operating it through months and years is very low as well. And it is low power because, again, it is not cellular data, but it is USSD. It is MQTT SN, which allows us to be more power efficient. And today, it really is the only truly global available network. Thank you very much. I hope this was insightful. If you have more detailed questions, you're very welcome to join us at our booth at C320 if you have